something to move from one point to another. We tried pi over 2, that was pi. Yes?
Would we add, 4 pi over 6 in the center?
You mean add 4 pi over 6 to what we have up here already?
Yeah.
Now, if you had 4 pi over 6, wait, that would make that 5 pi over 6.
Oh, I mean, add 3 pi over 6.
Oh, add 3 pi over 6.
Yeah.
Hang on. If I add 3 pi over 6 to this, pi over 6, that's 4 pi over 6. Add 3 pi, 7 pi over 6. 10 pi over 6. Maybe 13 pi over 6. So it's not adding 3 pi over 6. You guys are somewhere around this. You're trying to find that number I need to make this work. Should Ramsey go ahead and just show you how to find it? How to find that number? Okay, here goes. Can anyone tell me right now at this point, what is the period of this graph? Do I have enough on the board right now for you to at least tell me the period of the graph? I heard it. Hang on. The period would be the ending, 7 pi over 6, and that's cycle. Subtract the beginning. That's what, 6 pi over 6, which is pi. Is that true? Well, that's what's going to happen. Think about it. Back on the parent graph, from here to here, the period was 2 pi. And I was spacing by pi over 2 on it. So the period was 2 pi. What did I do? Maybe give you something that you might think of on the parent graph. It's 2 pi for the period, and I was spacing by pi over 2. What could I do with that period of 2 pi to come up with that spacing number of pi over 2? Sounds crazy. Ooh, divide by, whoa, divide by how much?
4.
Woo! 2 pi, divide by 4. There's the spacing number for the parent. Why did you choose 4 and not 5? Why did you choose 4 and not 6 to divide by? No, there's something special about that 4. Why not 2? Why not divide by 2? Why not divide by 8? Why divide by 4? There's something here that tells you maybe it makes sense to divide by 4.
Fill with the middle of the fill with the center of the period.
Something easier.
Because there's 4 sections.
Yes, there's 4 quadrants. Right here. 1, 2, 3, 4.
Why did you do
That's
that?
why you divide by 4. There are 4 quadrants. By the way, are there 4 quadrants always? So if I divide by 4, now wait, let me go back to my period here. We said the period was what, pi? So if I want to know what that spacing number is, that June was given to me, we're going to space by that period divided up by 4, since there are 4 quadrants. So PK, I'm going to go back here and add pi over 4. Boy, I chose a hard problem on that handout to begin with. I'm going to add pi over 4. On the parent graph, we were adding pi over 2. So I'm going to add pi over 4 as I move along. Trouble is, I've got a 6, and I need to add this to it with a 4. What would help me in algebra to make this a little easier on myself? So it's like adding fractions. I got 1/4, 1/6. I got 1/6, I'm trying to add to it 1/4, which may have required what when I do this? 1/4 from algebra, from arithmetic. You need a common denominator. Sometimes you don't, but I do. So it'll be easier to put all this in terms of a common denominator. And I've got a 6 to work with, and I've got a 4 to work with. What's my common denominator for 6 and 4? 12. Let's put everything in terms of 12. Make it much easier. Let me go back. Period. I guess where are we? Oh, here. Guys, pi over 6 in terms of 12. Can I write that as 2 pi over 12? Yes or no? And down here, in terms of 12, what is that, guys? 14? I did it quickly. Over 12. Yes or no? And I'm adding to it pi over 4, much easier expressed as in terms of 12, 3 pi over 12. Which I think one of my students that in mind, something like this. And this 3 pi over 12, so now it's much easier to just go through and add 3 pi over 12 to fill in those missing spots there. 2 pi over 12 plus 3 pi over 12 gives me what? 5 pi over 12. Add another spacing of 3 pi over 12, 5 plus 3, 8 pi over 12. 8 plus 3, 11 pi over 12. 11 plus 3, 14 pi over 12. Are they now even spaced? Oh my goodness, what did Randy have in mind to give a problem like this for? Was that the first problem? Okay, got the spacing done. And we go back to my original problem here. Oh my goodness. By the way, guys, all this has been done. We don't have the graph yet. This has been done here. All is done. So if you'd like to mark that out, you don't have to look at that any longer. I'm not quite finished. Now I gotta show the effect of this and a stretch of 3. So my graph's gonna be upside down. It's gonna be reflected through the x-axis and stretched by 3. And I gotta follow my 5 critical numbers. Guys, start me out.
We'll just reverse it.
Yeah, it started up here. Now mine's going to start where?
Negative 1.
Negative 3.
Or negative 3.
Is it negative 3?
Yes, yes.
And that's going to be right here. Where am I? Yeah. Are we upside down? My next point, is it going to be on the axis or not? Was mine on the axis right here? Will mine be on the axis?
Well, right here. We're gonna check this before you take a break here.
8 pi over 12, can anyone tell me where 8 pi over 12 might be located in the graph? Based on the graph being flipped over, reflected through the x-axis.
3.
Thank you. Wow.
Hang on. I know we're a little bit beyond the break.
11 pi over 12, I would think it's where? Next one coming up. Is it right here?
Same as mine. Mine's.
Right here? Is it on the axis?
Yes, yes, on that.
Yeah. Don't scare me.
That's fine.
And finally, this one, the parent was up here, mine's flipped over, it's down here. Wow. Connect those, if everything is wrong, it's something like that. Selena, we're hoping, at least does this purple graph look like this one flipped over, the x-axis? That's right, the purple graph looks like the parent graph flipped over the x-axis, and that's what we said should happen. And also it should be stretched by 3. My parent graph went up to 1, looks like mine, this one should go up to 3, it did, and down to a negative 3. So at least those things agree. Is that true, guys? And there's one cycle of the graph. You said, Professor, what do you have? I now have the graph of this. There's the graph. I did not go through all those transformations. Now, I know it's time for a break. Here goes. Close down. You got definitely a 15-minute break. I gotta do this. Number 1, can anyone tell me, what do you think the domain, we'll put a little subscript of F for function. What do you think the domain on the entire function, because you know these cycles repeat. I could pick up here and draw another one. I pick up here and draw another one. And on the left, same thing, I pick up here and go up and draw another one. Up and draw another one. So what do you think the domain for everything is? Negative infinity through infinity. Goes on forever. That's my domain. The range on the function, not just this cycle, function, the up and down, how far down does it drop? Negative 3. Now, if I should draw another cycle, is it going to drop any further down? No. Just bracket, negative 3 up to what? 3. Now, do I have my purple graph? You draw another cycle for me. It's going to drop down to a negative 3 up to a positive 3. Number 3, the period. I think we determined the period earlier to be ending, subtract the beginning. We're what? Time. That's the period of the graph. Makes things repeat. Oh my goodness. Hang on a second. period was pi, okay, for example, 14 pi over 12 is where I stopped. 14 pi over 12, suppose I add that period number to it, which is pi, which is what, like what, 12 pi over 12? I want to comment on the 12 pi over 12. So if I add 12 pi over 12 to this, just for an example, that takes me up to what, 26 is it? 26 pi over what, 12? Did I do the arithmetic correctly? 14 plus 12, is that true? So out here, if you should go out further, when you finally reach 26 pi over 12, PK, guess where the graph is? -3. That's what the period number gives you. It tells you what it will do. It's going to repeat those values. Okay, so we'll be at -3 out there. So I'll point that out. Number 4, no amplitude. Hang on. Oh, yes, there is an amplitude. Yeah, I think I hear, what's the amplitude here? 3?
Yes.
That's the highest number it goes up to, absolutely, there's an amplitude here. Amplitude period, geez. Now, before we do first. Joseph, here's really the way to check this. Professor, you did so much. Is that purple graph, Professor, really the graph? Here's a real test. I'm gonna say, choose one of these 5 critical numbers. Just choose one. And find f of, algebraically, how do you choose 8 pi over 12? Just randomly, I'm gonna choose 8 pi over 12 of the 5 for a reason. By the way, I'm going to go ahead and reduce that down, probably be better as what? 4 pi, I mean,
Or 6.
or divide by 4, what is it, 2 pi over 3? 2 pi over 3? Let's think of it as 2 pi over 3. Watch carefully, then we'll take a break here. Gotta see this stuff. Now, if I say do it algebraically, Professor, the graph, hang on, the graph shows me at 2 pi over 3, which is this. Just reduce down. The graph is up at 3. The graph says at 2 pi over 3, the value should be 3. When I do it algebraically, by directly plugging in, I really get 3. The graph says the answer is 3. Okay, let's try it. Go back to the original. Here we go. I'll take a break here. Pi over 3, subtract 2 times 2 pi over 3. Place that in there. Close that up. Close that up. We're hoping, here it goes. Let's do a calculation. -3 cosine. Guys, inside here is pi over 3. Oh my goodness. Is that minus 4 pi over 3? I'm not on top of the board here, is it? Is this right here 4 pi over 3, guys? Like the arithmetic here? Now I got -3 cosine, like fractions. Inside there, pi over 3 subtract 4 pi over 3 is what? -3 pi over 3. Is it -3 pi over 3?
Yes.
Better expressed as negative pi. Arena, we classified cosine earlier as being an even function. So if I'm wise, since it's even, could I even help myself out and say, I'm going to just drop this negative sign? That happens for all even. And now we end up with -3. Now, can anyone remind me, look at this, on the unit circle, what was the x-coordinate cosine at pi? -1. Was it -1?
Yes.
X-coordinate cosine at pi in the unit circle? And what's a -3 times a -1? 3. And what's my graph showed up at 3 at that point? Does the graph agree? My algebra agree? Now when you'll get nervous on the test if you check one of these, and all of a sudden, oh, professor, I did all my business, I got 4. Something's wrong. The graph says you should have got 3. Philip, we're gonna take a break, but I'm not gonna test anymore. But if you should go through this right here with maybe 5 pi over 12, and you do the algebra like I did over there with 5 pi over 12, the graph says the answer should be what? 0. around the axis. If you don't get a zero, you've done something wrong. That would be a good way to check, see if that graph makes sense. Guys, pretty good?
Yes.
Wow. Okay, I'll switch over. So guys around, what is that, 220?